Alright, today I'm going to begin to talk about solving systems by substitution. It's just another method of solving systems. We could continue to use the graphing method, which we learned yesterday, but now we're going to use another method. This will actually give us the exact answer rather than having to guess where two lines intersect if they don't intersect at an exact whole number. So there's three things that can happen. Remember that you could have one solution if the lines intersect. You could have no solutions if you have parallel lines. When we have substitution and we have a no solution, it will turn out something like this, where we get an untrue statement, 10 equals 3 or 6 equals 7 or 8 equals 5. When that happens, we will go ahead and say that there is no solution. When you have the same line, you'll end up with an equation that says like 10 equals 10 or 0 equals 0 or 5 equals 5. So a true statement, and what we'll write for that is that there's infinitely many solutions. So what we're going to get ready to talk about the steps for substitution. And what we're going to do when we solve using substitution is you're going to look for an equation that has either a variable with a coefficient of 1, or the variable or the equation could already be solved for y or x. That's the ideal situation, because if the equation's already solved for y or x, then we can just jump to step number 2. What that allows us to do is make a large substitution, and it'll give us an equation that has only one variable that we'll be able to solve, and then we'll take that answer and we'll plug that back in. So let's see how this works in this problem. This is the way I like to do this. I like to take the equation that has the variable all by itself and write it on this left-hand side. That is step number 2, to get an equation of x or y all by itself. Step number 3 is to actually substitute. Well, what are you substituting? Well, I'm going to replace y with what it's equal to. It's equal to 2x minus 4. So I'm going to take this box, that's what y equals this rectangle, and I'm going to put this rectangle in for y. So I'm going to rewrite everything that's there except that y I'm going to put a rectangle there for. So I'm making a substitution for y. And what I'm going to do, instead of writing y, I wrote this rectangle. Well, I'm going to fill in the rectangle with what it equals, 2x minus 4. So what this really says is it says I have 2x minus 2 times 2x minus 4 equals 8. Now what I can do is change my signs to plus the opposite, and I can distribute so I can solve for my x. So I get 2x plus negative 4x plus negative 2 times negative 4 is an 8 equals 8. Solve by combining like terms. Move the 8 over by subtracting 8. And then divide by negative 2. This gives me x is 0. The last step is to take this and plug this back in. Why are we doing that? Because we should get, if we're going to have a solution, it should be an xy ordinary pair. So I have the x part is 0. Where am I going to plug this back into is I like to do this whole circle type thing. So I'm going to take and plug that 0 back in up here. So I get 2 times 0 minus 4. So I replace my x with 0. That gives me y equals 0 minus 4. So I get y equals negative 4. Now, just like with the solving systems graphically, you can also check your solutions for systems. Or for substitution. If you want to know if this is right, you take the 0 and plug it in for x, you take the negative 4 and plug it in for y, and you see if it's true. This gives you 0 minus 4, which is negative 4. Now, if I plug in 0 for my x here and negative 4 for my y, I get 0, and this ends up being negative 2 times negative 4, which is a positive 8. So both of these are, 0 and negative 4 works in both equations, so I can be assured that I have the correct answer. Alright, another example will be something like this. However, in this problem, the y is not by itself on either of the two equations. So the first thing we have to do is actually solve one of the two equations for y. And I'm picking y because there's a coefficient of 1 there. So I will just subtract 2x from both sides, and I get y equals negative 2x plus 7. So this is going to be my box and what I substitute in. So my other equation is 3x minus y equals 8. And like I said, we're going to replace y with the box. So we'll copy everything straight down, except y becomes the box, and then equals 8. So we're going to put whatever y equals in the box, and that would be the negative 2x plus 7. So what this really says is negative 3, or it says 3x minus negative 2x plus 7 equals 8. I'm going to change the color of the pen so you guys can see that I'm distributing this negative through. So I have 3x plus 2x minus 7 equals 8. So I'll add 7 to both sides. Actually, let's not do that just yet. Let's combine like terms first. That's typically what we'll do. So we have 5x, because I add 3x and 2x together, minus 7 equals 8. I could add 7 to both sides. I get 5x equals 15. Divide by 5, and x is 3. Then what we need to do is we need to make an ordered pair, x comma y. The x value is 3, and the y value we find by taking this and plugging back in. So we get y equals negative 2 times 3 plus 7. So that would be a negative 2 times 3 is a negative 6 plus 7, which is a 1. So my ordered pair ends up being 3, comma 1. Now you could take that and plug that back in to see if the solution works. Moving on to another example. Again, we don't have an equation that has y equals or an x equals, so I'm going to take this first one and I'm going to solve it so that it says y equals. I'm not picking the second one because there's a negative in front of the y, so it just is one extra step. So I've got a negative 3x plus a 4. This is what my box is. This is what I'm going to replace y with. My second equation then, I would write down, my second equation I'm going to write here, and then I'm going to replace my y with the box. So you bring everything straight down, replace the y with the box, equals 6. What goes in the box is a negative 3x plus 4. So what that really says is negative 2 minus negative 3x plus 4 equals 6. At this point, I'm going to distribute my negative through. So I get 2x negative negative makes 3x plus negative 4 equals 6. Combine like terms. I get 5x plus negative 4 equals 6. Add 4 to both sides. I get 5x equals 10. Divide by 5 on both sides, and I get x is 2. So I started to get my solution. My solution is xy. My x value is 2, and my y value I can find by plugging that back in. So y equals negative 3 times 2 plus 4. So my answer would be negative 3 times 2 is negative 6 plus 4, which is a negative 2. So my solution is 2, negative 2. Alright, in this last example, what I have is an equation that has a negative 1 for a coefficient. So it's going to require me one additional step to solve for y. So I'll subtract 2x from both sides. And then I still have my negative y equals negative 2x plus 7. So then I end up having to divide by negative 1 everywhere. So what I end up with is y equals 2x plus negative 7. So this is what my box equals. So I'm going to take my second equation and I'm going to substitute in for y, the box. So I have copying everything else straight down except for the y. And then I'll put inside my box what y is equal to. So what this really means is that I have parentheses here. I am going to go ahead and show you that my sign changed here so you can see I'm distributing a negative through. That's one of the mistakes we'll make more than anything, so we want to make sure we do our sign change. I get negative 4x plus 14 equals 14. So when I combine my like terms here, I get 0. Those cancel out and I get 14 equals 14. Well, this is one of my special solutions. So if I take you back to one of my prior slides, there was 3 things that could happen. We could have one solution, which we've been getting over and over. We have no solutions if we get an untrue statement, or we can have infinitely many solutions if we get a true statement. So in this answer, right here I have a true statement, so I know that it actually has, or is the answer, infinitely many solutions. So it means I have the same line. Another way you can tell if you have the same line is if you solve both of these for y, you actually would see that you would get y equals 2x minus 7 for both of them. But having this true statement also means that there's infinitely many solutions.